Welcome back from an ad break. So as we have said, we're going to be focusing on 3 different concepts here that are related to pressure. So our first one is, what is pressure? So we're just going to quickly look into that and see what is pressure. So gases have much lower densities compared to solids and liquids. So now what does that mean? It means for the same amount of the substances, that's now being the mass. So for the same amount of the substances, gases will have a higher volume as compared to the same amount of liquids or solids. So now to put it into context, the equation for density is mass over volume. So for the same amount being the mass, when the density increases, the volume needs to decrease. So we're saying that the gases have a much higher volume as compared to the solids and liquids. So if the volume for the gases is very high, so that means their density must be very low, as we have said there. With that said, small masses can be difficult to measure without a special super-sensitive scale. So we have small masses of either the gases or the liquids or the solids. They are going to be extremely difficult for us to measure without a super-sensitive scale. So now, which is why the scientists have devised a different way of measuring how much gas we have. So because we know that gases, they are very difficult to measure because of their masses. They are very, very, very tiny. The mass of just one gas particle is extremely low. We cannot be able to measure it just by putting it on a scale and measure its mass. So we need that super sensitive scale for us to be measuring just either one gas particle or 2 or even 10 gas particles, because their masses are very, very, very small. Now, gases, they contain millions of fast-moving particles. Remember that we said all matter is made up of particles that are always in a motion. So therefore, the gas particles, they contain millions of fast-moving particles, right? So the gas particles that are always in a constant motion inside a container, they are going to collide with each other and also collide with the walls of the container. So if you put in 5 gas particles inside a certain container, and because they are always in a constant motion, there's going to come a point where they collide with each other and also collide with the wall that is in that container, or the wall of the container. We can take you for an example, that you and your 5 friends are gas particles. If we were to blindfold you and lock you inside a room and say you just need to move around, there's going to come a point where now you as the gas particles are going to collide with your friends or your other gas particles that are in the container, and then also collide with the wall of that particular container. So that's what we mean by that. So now we're saying that as the particles move around, they bump and bounce off each other. That's now you and your friends as the gas particles. You're going to bump into each other and move around in that particular container that you are in. And also, not only are you going to bump into each other, you're going to bump against the inside of the container, which is now the wall of the container, right? And furthermore, the force of the particles bumping against the side of the container causes the phenomenon called a gas pressure. So as you are bumping against the wall of the container, the force that you are exerting onto each other, it gives rise to this phenomenon, which is called the gas pressure. So now, what do we mean by that? What is gas pressure and what do we mean by that? So, the number of bumps or the number of collisions will depend on the number of gas particles in the container. So that means if I were to put 10 of your friends as gas particles inside the container, that means obviously there's going to be more collisions because there's more of you that are going to be colliding with either each other and also with the wall of the container. So that's why we're saying that the number of bumps or the number of collisions will depend on the number of gas particles that are inside the container, which translates to more particles inside the container means more collisions, and more collisions means a higher pressure. Remember we said, when you are colliding with the wall of the container, now the force that the wall and yourself are exerting onto each other gives rise to a phenomenon that is called the gas pressure. So because there's going to be more collisions, because now there's more particles, there's more gas particles in the container, there's going to be more collisions between the gas particles themselves and also between the gas particles and the wall of the container. So because of that, there's going to be a higher pressure, because a higher pressure is going to be measured by the force between the gas particle and the wall. So as we can see on this picture here, We have gas particles inside the container that are moving around chaotically in no particular order. They are colliding with themselves and also colliding with the walls of the container. And as they are colliding with the walls of the container, the pressure is increasing because there's more particles. So on this picture that we have here, there's less gas particles as compared to this one, which then means the pressure on this picture is lesser compared to the pressure on this picture here because there's more particles that are colliding in that particular container. So then we are saying if we can measure the pressure of the gas, we will have an idea of how much gas is inside the container. So by measuring the pressure that is exerted by the gas particles onto the container, we can have a sense of an idea of how much gas particles are in there. The higher the pressure, that means there's going to be more gas particles. So we can estimate as to say how much gas particles are in that particular container. So now, on to our next concept, which is now how can we then measure the pressure that we're talking about. We've seen how the pressure can be given rise to by the force exerted by the wall of the container and the gas particles. But then now, how are we then going to measure that particular pressure that we are talking about? So we have seen someone that is checking their tire pressure of a car. We have seen someone in a garage that is checking their tire pressure using a certain device. So now, we may have seen them use a device like this one that is given here on this picture. Now, this device is called a tire pressure gauge. It's a tire pressure gauge. This device, it is specially designed to measure the air pressure inside the tire. So they are using this device to measure the pressure that is inside the tire. And we do know that if now the pressure is measured using this device, we can also now find out how much air pressure do we need to add onto the tire or how much air pressure do we need to let out of the tire, because we want to keep our pressure at an optimum level of the tire. So when we are measuring the gas pressure, we are going to be using that particular device. That is assuming that now we are looking at a tire and measuring the gas pressure of a tire. We can also have another device that we can see on this picture here. So on this one, the force that is generated by many gas molecules, they push out the bar at the back of the gauge. So this is also another gauge which is measuring the pressure of any particular of any particular substance that you want to measure the pressure of. So by so doing, the force that is generated by the gas particles or by the gas molecules inside, it is going to be either pushing the metal bar away or into the device here. So we are seeing that as the volume increases, as this metal plate is pushed far back, we are saying that the volume of the container is increasing, because now the gas particles have a larger space for them to be colliding. And as we are increasing, as we can see, as we are decreasing now the space inside the particle, inside the container, the pressure is increasing. So now that gives us the relationship between pressure and volume, that when pressure is increased, the volume must decrease. And when we increase the volume, we are decreasing the pressure. So when we are decreasing the volume, the space inside the container, the pressure, it is increasing. But when we are increasing the space or the volume of the container, the pressure is going to decrease. So the relationship that we are looking here is that you're looking at here is that when the volume is increasing, the pressure is decreasing. And also, when pressure is increasing, volume needs to decrease. So they have that relationship that when one increases, the other one needs to decrease. So for this particular device that we have here, the pressure inside the tire is indicated by how far back the bar inside the gauge is pushed backwards. So as long as now this metal plate is being pushed backwards, we can be able to measure the pressure that is exerted onto that metal bar, as we can see on this picture or on this animation that we have here, that as the volume is decreasing, the pressure is increasing. As the volume is increasing, the pressure is decreasing. So right, learners, before we move on to our next concept, let's just quickly go for an ad break, and I will see you just after this.